All right, I already wrote down the title in purple, so I'm sorry about that, but we'll fix it. Okay, now, so last time we were here, we talked about a normal distribution, right? We said that something can be normally distributed, which means that what is at the center of the graph?
The mean.
The mean. Excellent. And we end up with a certain number of divisions on either side. How many divisions on either side of the mean? 3. And each one of those is called a standard deviation. Good. And we looked at the notations for those. Remember that mean, the simple letter mu, right? Then standard deviation, the Greek letter sigma. Okay? All right. So we have, this is mu, but it's probably not mu because it sounds like a Texas cow, doesn't it? Mu. And sigma. So remember, the mean is right here in the middle. And then there are three standard deviations either side. And it is symmetrical, meaning exactly the same on both sides, right?
Do we have to remember that it's called that? Will they in the actual thing, will they be sigma or will they?
No, they won't say sigma. They'll give you the symbol.
Okay, cool.
Yeah, they won't do the word. Yeah. Okay? All right. Now, and we talked about the fact that we can find probabilities if we know where the data lies on the curve, right? Okay? And so today what we're going to do is I'm going to just give you some shading, and you're going to tell me then what keystrokes you would use for that particular one, and you need to describe the shading. And I'm going to give you one. Let me do the first one for you to show you what I mean. Okay? So let's say that we have, this is our curve. Right? And I have a little line right there, and I've shaded this. Okay? I know it doesn't have any numbers in it, doesn't have any standard deviations. I just want you to concentrate on the shading. Okay? This one is shaded in which direction? Well, just where's the shading? On the right-hand side, right? Do you agree? Okay? If the shading is on the right, then we're talking about an x value that is bigger than some number. Do you agree? Because we're shading bigger than whatever this x value is. Again, I don't care about the numbers. I just want you to tell me where's the shading. Now, if I was going to do this, the keystrokes for this, then this x value that I have would be one of my limits. Which one? The lower limit. Good. So we would have a lower limit of whatever that x number is, right? Okay? And what would be our upper limit? Exactly. Good job. Right? Because we want to make sure we get all the data up there. It's way bigger than you need, but we need to get all the data that's to the right. You agree? What other pieces of information would I have to have in order to work this? The mean and the standard deviation. And those are always going to have to be given to you, right? So that's why I'm not bothering with those right now. We're going to do some examples. But right now, I just need you to do this, to think about the shading. If you do not draw this and shade it correctly, then you will not get an achieved. Okay? And achieved is kind of where you need to be, at least, right? Okay. If you do not list these pieces, you will not get an achieved. Make sense? Because you need to write it out. Then you're going to have to also write out the steps on your calculator. What did you enter to do this? So, can anybody take me through the keystrokes? First, you go to what? Menu. Oh, yeah, it's menu first, isn't it? Menu. And then see I drew a little arrow? What does that mean? Next, right? Stats. Then what?
Distribution, which is F5.
Distribution, right? And you could put F5. It wouldn't kill anybody, but I don't think it's really that one's not there. Okay, then what? What? Norm? Right? Then what?
NCD.
NCD. Okay?
And then make sure it's on variable.
Then make sure it's on variable. Then what?
And then you put your limits.
Then you put your limits in, right?
Yeah.
Which one first?
Lower limit and
Lower limit. Then
upper limit.
upper limit. Excellent. Y'all are good. And then
The sigma, which is this deviation.
standard deviation comes next. Remember, they're reversed from the way we usually look at them. We usually think of the mean first. And then finally the what?
And then the mean.
Then the mean. And then, do you have to push execute or not? Yeah, to get your final answer. We happy with that? Okay, so make this list. Know these keystrokes.
You can just say, like, if it's like, if you're writing down the steps, you write out like things at like button, or if you press like F1 for.
Now you don't need to write out every button. Just which things they mean.
Okay.
So you don't have to show like F1 is the one for this or whatever.
Yeah.
Just the whatever key. Just whatever. So you don't have to name the key that you have to push to get it. That just what it means. Okay? All right. Everybody happy with that? Everybody hate it? You're going to. By the time you're finished with the test, you're going to be thinking, this is so dumb. Why do I still have to be writing this? But that's what it takes to get an excellence, which is what I expect all of you to get on this test. At least this part. Just write this down every time you do one of these, and you'll have it in your head so ingrained in your head you'll never forget it. Okay.
Do you need this for a sheet or for?
No, you need all of write every bit of that down. That all of that I wrote, including the probability, the answer, would get you an excellence.
Oh, okay.
Okay? If it was an excellence question, of course. Now, all right, here we go. Here's another one. Got your curve, got a line, and I've got some shading. This is my x. So what is my lower limit? There you go. This time, the lower limit goes forever over, right? And the closest we can get to that is negative through 9 nines, right? 6 nines, I'm sorry. What is my upper limit? Whatever my x value is. Good. And then what other two pieces of information do I have to have? Standard deviation and the mean. Okay? Will the keystrokes change? No, so I'm not going to write them all down again. But you should, every time you do one of these problems, write it down. Even though it's going to take a little time, it's going to make you memorize it. And then you won't have any problem when you start the test. Because when you start the test, I am not allowed to tell you if those keystrokes are right or not. Okay? So you can come up here and say, is this the next thing I need to push? And I'll have to say, I don't know. Okay? So be careful. And you're not allowed to talk, and you're not allowed to have notes. Okay? All right. Okay? Here we go. There's another one. Got a line here, and I got a line here. And I'm just going to call these X and Y so you know the difference. And the shading is between them. So the shading between them means that there's a definite what? Upper and lower limit. You betcha. Okay? What's my lower limit in this case? X. What's my upper limit in this case? And what else do I need? Standard deviation and a mu. Right?
Can you just put LL, or you have to fully write out?
You can write LL. I'll probably be grading them, so I'll know what LL means. Yes?
And the shaded area is on either side.
No. Good question. That's my next question. Don't steal my thunder. I got to have something to do. Okay. Here we go. Got a line there, got a line there. I got some shading at this end, and I got some shading at this end. And that's an X, that's a Y. I got an issue.
Yeah.
Now, there are two ways to accomplish this. Okay? I could find this area using X as an upper limit. Find this area using Y as a, and then do what to them? Add them together. But if I were clever, I would use this using X and Y, using X as my lower limit, Y as my upper limit, and then subtract it from 1. Why 1?
Because it's a probability of the complement.
Because the whole probability is 1, right? And so this would be finding the complement of that. Okay? And that's the beauty of using the calculator instead of the chart. You wouldn't be able to do that on the chart. You'd have to find both and then find, first you have to find the z-scores, then find all, etc., right? And find them and add them. But using the calculator, you can find the complement and simply subtract that from, again, what number? 1. Okay? So simply use your lower limit as X, upper limit as Y, and then, of course, the same other information, and you get that number and simply subtract it from 1. Because we know that the whole graph has to equal 1. So if we know any one part of it, we can find the rest of it by subtracting it from 1. Okay? Excellent question. Thank you. Okay? Yes?
Where do we find your voices?
You would find them on YouTube if I had posted them yet. But I shall post them.
I subscribed to you.
You subscribed? Good job. That's pretty stoked. It's just Russell Self. Yeah.
So all of these would be excellent that we've just done.
Yes, if you had described the keystrokes as well.
Okay, cool.
Okay?
Do you have described keystrokes on test?
Yes.
You just write keystrokes? Or just like show your roadmap? But
Okay.
if I'm on like
Okay. I'm gonna say we need at least 3 decimal places. Don't worry about the average rule for how many decimal places is, because it is the same as how many you started with, because this is always going to be very few in your original problem, if any. Sometimes you won't have any. So I would say at least 3. But if you look in the back, what does it say?
The question has 4 of them. I usually do 4.
They did 4?
In this book, they normally do 4.
Well, then let's do 4. So it's one more 8 or a 9?
Like 7, 7.
Oh, what now? 0.78.
7, 7.
77. Okay, there we go. And that's properly rounded, right? Not just truncated. 7877. Okay? So if this book's doing 4, then let's do 4. Did you just switch back? Okay. Oh, I don't know what y'all are doing. Okay. All right. Looks good?
And this is the one where you can put like norm and dist and everything in.
yeah.
Yes.
Cool, cool.
Put in your keystrokes and put those in. Okay. Again, I'll find out if it's absolutely necessary. Because if it's not, right now, I think it's absolutely necessary because you really need to fix it in your brain. Okay? But what is necessary for sure? The drawing, the pieces, and the probability needs to be given using the correct notation. Right? We haven't done any of that in a while, so we need to make sure. Okay? Now, there's a B part. Calculate the probability the American spends less than 20 or more than 70 minutes on social media per day. So, less than what? 20 or more than 70.
So this is the one where it's the 2 tails, eh?
I can't write that as one inequality, can I? Something can't be less than and more than at the same time.
So would you put P and then like X is
Probability
and you put or?
that X is less than 20 and probability that X is greater than 70. It's two distinct probabilities, right?
But you can do it.
It's not between. Now, you can write it as one, but you're going to use two inequalities. And let's see. So you could say probability X is less than 20 or X is greater than 70. But if you do it, you have to put the word in or in there. And it can't be and. Because what does and mean to do? Multiple, yeah, at the same time, and it can't be at the same time. It would mean you multiply those probabilities. And in reality, what we're doing is adding those probabilities. So it's or. Okay? All right. So let's draw our curve. There we go. Our mean, again, is 40. Curve is going to look exactly like the last time, right? Because it's the same data.
If your curve isn't very symmetrical, but it has
It's
the
fine.
intention of being
It has the intention of looking like a curve. It's fine. None of mine are perfect. And then you'll have your values in there, right? Okay? Whatever they are. Don't be lazy like me. Be good like y'all are. Okay? Now, we're going to put in our information. Less than 20. Oh, I should have put my numbers in there. But I can look at it. 20 is slightly lower than 2 standard deviations. Ah. They have been labeling the axis, haven't they? I did. So I think you should label it as minutes on social media. And again, I'll check again to see if that's going to be a make or break situation. But it won't kill us. Okay? At the very least, you should put minutes. Right? You do need to understand the units, so you do need units on there. Did y'all see that, guys? And I didn't do that on the last one. So this should be minutes at the very least. The more descriptive you can be, the better. It's never going to hurt you. Now, and above 70, if we go back, this is 69.1 is way over here at that standard deviation, right? So 70 is slightly above. Do you remember it? That's 69.7 or something like that. So 70 is right above that. So this is a two-tailed one. No, just above there. It's just, yeah. Yeah, it's just right behind the third standard deviation line. Okay? All right. Now, we can do this, guys. But remember that what we're going to actually find is we're going to find this area inside, which is not x, but x prime, the complement of it, right? Okay.
We need to put X prime in.
Yeah. So if we find x prime, if we use the numbers for x prime, then we need to label it x prime. And then after we subtract it from 1, then I can put it over here with the equal sign, right? But do not label this x, right? We're going to find x prime. What's our lower limit? 20. What's our upper limit? 70. What's our standard deviation? What's our mean? What's our value? I'm sorry, what now?
0.9794.
Thank you. All right, but that is not our value, is it? That's x prime. So we need to take 1 minus that value. Somebody? Can you go slower?
0.0206.
Thank you.
Can you do
My
like-
ears don't hear as fast as
You know
they
how
used
in
to.
the whole P equals x20 or whatever, can you do equals 1 minus x prime and then go down and go 1 minus whatever and then go equals 0.0226?
Yeah, as long as you note it, as long as you note exactly what's going on, or you can just say that you're finding the probability of x prime, and then do it either way. Now, let's check our number to make sure that nobody steered you wrong. Somebody want to check in the back and see what we get? Page 30. 0.0206. Look at us doing math. How exciting is that? Okay? Good deal. So now you know how to find those probabilities and the shadings in different areas. And again, because we're using the calculator, we can do this x prime business. Makes our life a lot easier. Okay? But that means you need to know those keystrokes backward and forward, which is why you need to write them down for sure while you're doing the homework. Right? Do you just trust that you're going to remember it? No. Okay? So be careful. So let's see. We didn't do page 28, right? So let's do page 28 and 31.
Oh wait, what's this for? For
Homework is page 28 and 31.
I think we said 221. 231. I was gonna cry.
Well, it pretty much is. Because the others are just examples on there. Okay? All right.